Kinematics is the study of the motion of objects. Now, terms such as displacement, velocity, and acceleration are used to describe this motion. And they are related by these graphs. For instance, a displacement denoted by S versus the time graph. If I were to draw its motion here, that slope would now indicate the velocity. And similarly, if I was to show you a graph of velocity versus time graph and look at its slope, that slope would now show you acceleration. Now, we've learned already before that when we find the slope function, we do it using derivation. If st is my, then ds dt will now be my velocity function. And dv over dt will now be my acceleration function. In other words, we can find velocity by differentiating the displacement function, and we can find the acceleration by differentiating the velocity function. Now, it is really very important to remember that these three terms have both direction and magnitude. Because they have direction, all these three terms we can have negative and positive values. Because motion of a particle can be drawn on a motion graph showing its position, we need to indicate the origin and so that we can show that the positive values are on the right hand side and the negative values will be on the left hand side by writing positive numbers and negative numbers. So our particle could be either to the right of the origin or it could be to the left of the origin. When our function is either greater than 0 or our displacement function is less than 0. So our velocity also has magnitude and direction. So when we describe velocity, we'll say that if the function, the velocity function is greater than 0, then we say that the object is moving to the right. And when the velocity function is less than 0, then we say that the object is moving to the left. Okay, so we've described the direction and the magnitude of displacement, and we also described the direction and magnitude of its velocity. And now we need to also describe the magnitude and direction of acceleration. Needs to be examined in relation to velocity. So if velocity is positive and acceleration is also positive, or if velocity is negative and acceleration is also negative, then in both of these cases we will find that the speed of the object will be increasing. On the other hand, if the velocity of the object is positive and acceleration of that object is negative, or the other way around, if the velocity of that object is negative and the acceleration is positive, okay, in both of these two cases, the speed of the object will be decreasing. And we use sign diagrams to interpret these motions. So for example, let's say that our displacement function is such, and we have units now because this is a displacement like centimeters. Then we can find its velocity. The velocity now can be found by doing a derivation of this. So we'll say that the velocity of this function is now 3t minus 12t plus 9. And to determine whether the object is moving to the right or to the left, we need to draw a sign diagram. And to do that, we are going to have to find the zeros of this equation. This can be done by factorizing, taking out the 3 first of all out, and we get, oops, that was supposed to be t squared, minus 4t plus 3. And now we're able to factorize further. So we'll find that t minus 1 and t minus 3. And this time the units will be centimeters per second. And the sign diagram now can be drawn. It must always, because it's the sign diagram is time, this is always going to start from 0, and then we'll start with 1, 2, 3, and our sign diagram will be at 1 and 3, and from 1 and 3 we'll get a positive, a negative, and a positive. We can now find the acceleration expression by differentiating the velocity. So we will now get to 6t minus 12. Okay, we'll factorize that as well, and we'll be able to find that that's t2 okay, and this will give us the sign diagram for acceleration. And once again, the time can not be any less than 0, so we'll do 1, and acceleration changes at 2, where it's negative on the less than 2 and positive on there. Okay, so now we've got the two sign diagrams. Okay, one is for the velocity and the other one is for the acceleration. Why do we need those two diagrams? Well, remember that previously I mentioned to you that we can find out whether the speed of the object is increasing or decreasing by looking at whether the velocity and the acceleration are both the same, or are they different? So if we look at this diagram over here, where we've got the sign diagram, look at this. The change at those points, where are they the same and where are they opposing? In other words, the speed is increasing when the signs are the same. So they would be in this area here between 1 and 2, and also between 3 and onwards, because we don't know where it finishes. Whereas in the other two places between here, what can we say about the speed? The speed here is decreasing. I'll mark this down so that you can actually see. So here we are decreasing. Here we are increasing. Here decreasing. And in this area it's increasing. We put it mathematically and we say the speed increases. The speed increases between 1 and 2, and it also increases when time is greater than 3. And the speed decreases between 0 and 1 and 2 and 3, which is written up here. Well, this information we were able to glean from both having a look at the velocity and having a look at the acceleration. But what else can we find out from this? We can find out from this the position of the particle when it changes direction. And this can be done by drawing a motion diagram for the particle. But first we need to establish the initial position of the particle. So at time equals 0, we can now substitute 0 into our displacement function, and we end up getting -1 centimeters, which means at the particle is 1 centimeter to the left of 0, or the origin as we should call it. Okay, so our particle is here at time equals 0 initially. Okay, let's look at the velocity at its initial time. The velocity at 0 time is going to be equal from a velocity function. It'll be 9 centimeters per second. This is a positive value, which means that it is moving to the right with a speed of 9 centimeters per second. But we also know from its sign diagram that, let's go to the sign diagram, that its velocity changes at 1 and at 3. That means its direction changes at these instants. So in reality, the motion diagram needs to show us the particle at 0, it needs to show us the particle at 1, and it needs to show us the particle at 3. So we already know that the particle at 0 is -1 centimeters. Now we need to find the particle at time 1. At time 1, it is going to be, we substitute these in, and we find that it's 1 minus 6 plus 9 minus 1, and our value should be 3 centimeters. And at time 3, we can substitute that inside our function once again, and it'll be 27 minus 54 plus 27 minus 1, and the particle will be at -1 centimeters, again to the left. So how does this play out on our sign diagram? Well, let's make sure that we've got origin over here, and 1, 2, 3 centimeters, 4 centimeters, 5 centimeters. We don't need that, but we also need to go left as well, because I know that my particle has started at 1 centimeter left. So if I start my particle 1 centimeter left from the origin, because this is my origin, what's happening after 1 second? After 1 second, we find that our particle is now 3 centimeters to the right. And it's been going that way for I believe, with a velocity of 9 centimeters per second. So it's been moving up that way. Now we know that it changes sign after the time 1, because this was at time 0. At time 1 now, after 1, it changes direction. That's what happens. And it ends up coming back to -1 centimeters. Here, let me just show that to you clearly. Here we are, -1. It was at -1. It went 3 centimeters to the right, and at 3 seconds, it's back to -1. So back it is over here again. So it means it's turned around again and it's gone back. Okay, that's the way. And this is at time 3. I don't know where it was after 2 seconds. I don't really care because it didn't change direction. All I was interested to know is when it changed direction. And so it changed direction at 1, but it also changed direction at 3. So we will need to change that direction, and it's continuing on this way. Using those 3 functions, we were able to plot this sign diagram of an object particle movement and finding out whether the speed was increasing or decreasing. And that's about it.